CIT 1122, Module 3, Section 2, VLANs in a multi-switched environment. What we're going to get into in this section is when we're connecting switches to other switches when VLANs have been added to our intermediary devices, to our switches. So we can look at some of the bullet points here. It says a trunk is a point-to-point link between two network devices. Okay, that sounds like a thing. And Cisco trunks allow for more than one VLAN. Extend the VLAN across the entire network. By default, a trunk will support all VLANs, and it supports a tagging method called 802.1q, which we'll look at in just a second. Now, what we didn't do is describe where the trunks are at within the section or what exactly a trunk does. So now that we've added VLANs into our repertoire of switching, and we're going to create port groups on the switches, those port groups are going to want to talk to other devices that are on other switches. So for instance, if we set up PC1 over here on switch 2 for VLAN 10, as it's listed here, this PC1 is going to want to be in the same broadcast domain as PC4 over here on VLAN 10 on switch 3, right? So those two devices should be in the same broadcast domain, and if they send messages to each other, they should be able to send and receive them. Now, those should be exclusive from the messages that are sent by PC2, which is in the student VLAN, VLAN 20. VLAN 20's PC2 is going to want to send information over here to PC5, which is a student VLAN on switch 3, and the same thing is true of the guest network of VLAN 30. PC3 is going to want to send information to PC6, and those broadcasts should be exclusive and only seen by the other devices in the same VLANs. So we have a couple of options. Option number 1, make a port for, and I'm just going to pretend like switch 1 isn't here right now. We're going to take a port on switch 2 and we're going to connect it over to switch 3, and we're going to associate it with VLAN 10. Okay, cool. Now PC1 can talk to PC4 because I've got a link here for VLAN 10. Now let's make another one here. And we're going to have to use more ports here for VLAN 20. Wow, that doesn't even look like the word VLAN at all. Let me clean that up a little bit. VLAN 20. VLAN 20 is going to get its own 2 ports. And then, try to get all the way around there. We're going to take 2 more ports on each one of those, and we're going to set that up for VLAN 30, and that'll totally work for us. Now, ports are at a premium. Maybe I don't have 3 extra ports on each one of these switches in order to make these connections. So what I'm going to do is this, is I'm not going to create links between switches per VLAN. What I'm going to do is I'm going to roll all the VLAN traffic into a single link between switches, which is called a trunk link, which we didn't totally explain when we got into this slide. So the trunk links here are going into switch 1 from switch 2 and switch 3, but the idea is this, is that we can roll the traffic from VLAN 10, VLAN 20, and VLAN 30 from switch 2. They can all 3 of those VLANs can make their way, send their information to switch 1. Switch 1 will then relay it down to switch 3, and when it gets to switch 3, there's going to be a tag value. This is where this 802.1q trunking thing comes in. 802.1q says this, is in addition to the regular frame header, we're going to add 2 more values. We're going to add a VLAN ID value, and we're going to add a prioritization value. We'll talk about prioritization when we talk about voice VLANs, but we're going to be able to add those 2 values into the frame header, and those can be read, and then that will allow these devices to communicate with each other. So when PC1 wants to send information to PC4, and it hits switch 2, in addition to the destination MAC address that's read by the switch is also going to read a VLAN tag that says VLAN 10. And then it's going to punch up a tag that says VLAN 10. This traffic's for VLAN 10. It's going to go to switch 1. Switch 1 is going to read it. It's going to say, oh, okay, so I should send that over to switch 3. Switch 3 is going to receive it. It's going to be tagged still and say VLAN 10. And it'll go, oh, I want to send this out the port that's associated with VLAN 10. I'll only send it out port FA0/11, and the secrecy or the privacy of the broadcast domains between the networks will be maintained. Hopefully that makes sense. Let's look at the next slide where we kind of break it down a little bit more. Protocol data unit section up here at the top. If we look at what's going on here, we have a PDU, and the PDU is broken up where they're giving us they're giving us the 3 sections of the frame header right here. So I'm just going to write frame header here. Frame header here has 3 parts to it, right? It has the destination MAC address, the source MAC address, and the type field, which tells the packet header what kind of information this is. Great. Now, when we change this frame header into or from, this frame header is called an Ethernet 2 frame header, by the way, Ethernet 2, and you have to write it like Roman numerals too. Otherwise, it's not cool. I don't know why it's like that, but it is. And so it's Ethernet 2 frame header, and we're going to change that into an 802.1q frame header. And the only thing that has that's different is this tag value here adds this piece. And this piece right here, what you should see here is type. This should just say, excuse me, over here, or it says vid. Vid stands for VLAN ID, which is going to be like 10, 20, 30, those other numbers that we saw. And then the other value that you want to be aware of here is PRI, which is an important value, which is prioritization. We'll use that in our voice VLANs, so we can increase the prioritization value of voice VLANs so that our voice calls sound good, even when we're passing traffic across to another VLAN that might be connected to that phone. Okay, so keep that in mind. So we've broken down all the fields here. Of these fields that I want you to be aware of, CFI, who cares? Goodbye. Get out of here. This type field is not that important either. User priority is, and VLAN ID is. Okay, so those are the 2 things that I want you to be aware of that are in that field. That brings us to the next part of 802.1q trunks. So now that we're going to start trunking things, we're going to start adding these tags, and the tags are going to identify the VLAN IDs. You go, well, if you go backwards in time, there was a time when we were just sending Ethernet 2 frame headers. So there's a special frame header that you're going to forward that isn't formatted as 802.1q. It's actually formatted without the tag, without that tag, without the VLAN ID, and that's called your native VLAN. By default, that's VLAN 1. So if you look at some of the bullet points here, tagging is typically done on all the VLANs, true. We're going to use a native VLAN. It was designed to use for traffic that is untagged. Unless changed, that's going to be VLAN 1. Now, for security purposes, we're going to tell you this. You got to change the native VLAN from VLAN 1 to something else. And then you can turn it off if you want to. But you can't turn off VLAN 1. So, I guess the default process would be, hey, why don't we just leave VLAN 1 as the native VLAN and then turn it off, and then we'll just set everything else up. But you can't turn off VLAN 1. So the workaround for that is take the native VLAN and make it a different number, and then basically don't use it for anything or turn it off. And then you've now stopped traffic from passing across the switches that is untagged. Only tagged traffic will then get from one place to another. So that's what you want there. Now, when do we have to tag stuff? And the answer is we only have to tag stuff really when we're between switches or from a switch to a router when we get into inter-VLAN routing. But we're not going to talk about inter-VLAN routing for 2 more days. So let's just talk about from switch to switch. So it's pretty straightforward here, right? If we look at our switch here on the left, this switch has VLANs 1 and 2 connected, okay? Now, VLAN 1 and 2 are going to send information to our other switches that are on the right-hand side here. So this particular switch here has information for VLAN 1. And this particular switch here has information for VLAN 2. Okay, so how do I make sure that they stay in just the ports that are set for those VLANs? Well, as the network administrator, I consistently put devices in VLAN 2 for a particular subnet, right? And I put devices for VLAN 1 in a different subnet, and we'll be able to keep track of them. So device in VLAN 2 sends information up to switch. Switch then sends message from switch to switch here, right? At this point, I got to tag it. This needs to be tagged as VLAN 1 or 2 because without that tag traffic, this receiving switch doesn't know what VLAN the information started from. So I have to tag it on its way in. Once it gets here, this switch can identify which interfaces it should forward information for VLAN 2. And it's going to say, oh, you know what? Only this switch has other devices on VLAN 2. I'm just going to send it there. And when it gets to this switch will receive it. And it'll say, oh, hey, the tag says VLAN 2. I'll send it out the interface associated with VLAN 2 to an access device. Now, as it rolls through the switch, the tag is removed. The end devices have no idea that they're getting connected or whatever VLANs they're on. The end devices have no clue that they're on the same VLAN or they're not on the same VLAN. It's only information that's necessary to go from switch to switch or from switch to an inter-VLAN routing router. Those devices need to know which VLAN the information was sourced from, because we're not going to figure it out based on network, because switches don't read IP addressing information. So we have to have a different value for that, and that's called the VLAN value. Hopefully that makes sense. All right, let's move on to next slide. The voice VLAN, we kind of talked about this. I think we've given this enough press. The phone itself is going to be on its own VLAN. And it's going to be on its own VLAN called a voice VLAN because we're going to be able to set up specific quality of service, cost of service values, which is just the prioritization field inside of the 802.1q frame header. And that being said, we can set that up so that we can have good quality voice traffic on that system. Okay.